So you stumbled across this video while you were on YouTube, and honestly, there are two reasons that you're here. The first one is that you're Tom grading my final project, in which case I would say, please be nice to me. I worked really hard on this and it was a tricky proof. Or the second reason is that you want to learn about the SSS statement similarity, which, as I already said, was a very difficult proof. And so I would highly recommend for you to one, reconsider why you're interested in this. And number two, then I would say if you are still interested in, it's going to be tricky. It's going to be a little bit confusing, but we're going to stick with it, try to not get ourselves lost, and it's going to be something really awesome. So let's just jump right into the proof. Here's an overview of the entire proof. As you can see, there are lines going everywhere in this flowchart because crazy proof. But we're going to hop in and go along for this ride. So to start off, let's look at the picture and what we're given and what we're trying to prove. So the first thing that we're trying to look at is the given. We know that HC is congruent to EF, AB is parallel to GH, and AB over DE is equal to BC over EF, which is equal to CA over FD. There's an SSS going on here. All the sides are proportional to each other, which is SSS in terms of similarity. What we're trying to prove is that all these angles are congruent, because if all the angles are congruent, that's the second half to knowing that these triangles are similar. If we prove that all of these angles are similar, it shows that the SSS similarity conjecture is not just a conjecture, but then can graduate to being a theorem. So let's start off by looking at these triangles. First, we have a larger triangle named ABC, and then we have a smaller triangle named DEF. So ABC, within it, has a smaller triangle formed by a parallel line, little auxiliary that we drew, that is GHC. And it's very important that these lines are parallel. It's also very important that HC is congruent to EF, and we're going to get into that as we go on with this proof. So to start, we need to say that AB is parallel to GH, which is one, a given, but also is from the parallel postulate. This then shows that GHC is congruent to angle B, and angle GCH is congruent to angle A. Both of these are due to the corresponding angles postulate. The fact that angle GHC is congruent to angle B and angle CGH is congruent to angle A is very important because of the fact that with these two congruency statements, we can say that triangle ABC is similar to triangle GHC due to the AA similarity postulate. Now that we have this information, we can go on to the next step, which is the fact that AB over GH is equal to BC over HC, which is equal to CA over CG. And that's due to the definition of a similar triangle, or you can also say CSSTP, but either one works. At least for this project, it is of course dependent on your teacher. Now let's go into the next step. The next step we're going to show is BC over EF is equal to CA over CG. So we have it given due to the segment duplication postulate that HC is equal to EF. This is important to note. Take the definition of a similar triangle, BC over HC equals CA over CG. Take that part and take this little given information that we have due to the segment duplication postulate. And take that HC equals EF and just boom, put it in there. Replace that HC below the BC with an EF. And there you go. The next step that we're going to take, this is going to be a roller coaster right now, and I'm warning you of this ahead of time, is BC over EF equals CA over FD. And we can just do that using the given. So once we have that, we can do something super cool that I am sure you guys are all really excited to see. And we're going to take those two things, boom, transitive property them. And now we've got CA over CG equals CA over FD. How do we know this? Because both CA over CG and CA over FD equaled BC over EF. If we have that fact, then we know that two things that are equal to the same thing are equal to each other, aka the transitive property, and that's how we've set this up. So next we're going to go through some basic algebra steps to get this to where we want, where we're saying that FD equals CG, which is ultimately our goal of this little detour we're taking. So first, we are going to use the multiplication property of equality to take that CA over CG and CA over FD and take that FD and get rid of it so that it's not bothering our CA. So now we've got CA over CG, FD equals CA, and we want to get rid of that CG. So we're going to, again, use the multiplication property of equality and make it CA times FD is equal to CA times CG. And now we want to get rid of that CA because we know that those can be easily canceled out since there's one on both sides. So we're going to use the division property of equality and make it FD equals CG, which is exactly what we were trying to prove. Now, I hate to break it to you guys because I'm sure you just worked just as hard as I did to do that, but we're going to do that again. So we're going to take the definition of a similar triangle, CSSTP, that we already had going on, take those ratios, take the HC equals EF, and write another proportion. BC over EF is equal to AB over GH. And we can again do that with the substitution property by swapping out the HC that we had above for the EF, because that is a given due to the segment duplication postulate, as I previously mentioned. The next step is take the given information of AB over DE equals BC over EF equals CA over FD. Take all of that, boom, BC over EF is equal to AB over DE. And so now we're back where we were before. So we're going to take the transitive property because as you can see, the only difference here is that the GH in the denominator and the DE in the denominator, which means that they can be set equal to each other using the transitive property. So we use the transitive property. We've got AB over DE equals AB over GH. Sorry I'm speeding through this, but we've already gone over this. So I'm hoping that your understanding is pretty rock solid at this point. Then we're going to take that AB over DE, add a GH to it, remove that from the other side because they canceled out, and just leave it with AB over DE times GH is equal to AB. And we can use the multiplication property of equality to do that. Then we're just going to do it again to the other side so that we end up with AB times GH is equal to AB times DE. Now, due to the division property of equality, we can just make it so GH equals DE. That's just how I like to do it because I like to do this as a math equation, although I'm sure there are other ways that you can do this. So now we can take that GH equals DE, that FD equals CG, and finally that HC over EF that was already given to us, and say that triangle GHC is congruent to triangle DEF. So our little triangle is congruent to the little triangle formed in the big triangle by the parallel lines. Wow, what a crazy journey we've already been on. And sorry to break it to you, but we're not even through the proof. So we can do this due to the SSS congruence postulate, which pretty much is saying that if a triangle has three sides that are the same length, they are congruent. Pretty cool, huh? So we're going to keep on moving. I'm going to try to finish this proof out strong. I know this has been a long one. From here, we're going to take this little congruence postulate, this little statement of congruency, and we're going to prove that some angles are congruent. Yay, that's our final step. So the first thing I'm going to do is I'm going to take the fact that angle E must be congruent to angle GHC due to the CPCTC. If you didn't know, CPCTC is an acronym that stands for corresponding parts of congruent triangles are congruent. Pretty much because we know that these two triangles are congruent, we therefore know that their corresponding parts, in this case, those angles described, are congruent. We're going to take that CPCTC, and then that little angle E is congruent to angle GHC. Take that, bada bang, bada boom. We can then, due to the fact that above we proved that corresponding angles postulate that says that angle GHC is congruent to angle B. Remember, these are both congruent to GHC, so we can use the transitive property, and now angle B is congruent to angle E, which was one of the three angles that we were trying to prove are congruent. Next step, angle D is congruent to angle CGH due to CPCTC, as before. We're going to take this knowledge that angle D is congruent to angle CGH, take the knowledge from above due to the corresponding angles postulate that angle CGH is congruent to angle A, slap those together, do some transitive property, and boom, angle A is congruent to angle D. And now, just with that knowledge, we can say that triangle ABC is similar to triangle DEF due to the AA similarity postulate. But let's be real, we already knew this triangle was similar because technically, if it has all three sides, which is what we're saying here, are proportional, it's got to be congruent. So we're just trying to prove that all angles are congruent. So let's do our final angle that we're missing. So, like before, we can take that SS congruency postulate statement that we've got going on over here. Use CPCTC to get angle F is congruent to angle GCH. Then we also have from the AA similarity postulate that angle BCA must be congruent to angle GCH because of the definition of similar triangles. Again, both of these angles happen to be congruent to angle GCH, which means that we can use the transitive property to show that angle BCA is congruent to F, the third and final angle we were trying to prove. Wow. I hope you feel like me, where, geez Louise, that was one roller coaster of a ride for a proof. There were a lot of steps there, but we really pushed through. We tried not to stop and get lost and get stuck, and we learned that, at least for this proof, transitive property was the star of the show. And having a parallel line in there really helped get us off on the right foot, and then we just rode the substitution transitive wave all the way to the end. So I'm feeling pretty excited about this proof. I don't know about you, but I worked very hard on this. So have a wonderful day and have a wonderful time grading these finals, Tom. And we'll see you in my second proof video.